Let's start. I will be turning off my webcam so you guys can concentrate on the presentation. Some people do watch from their cell phones. Okay, welcome to Index Online, webinar number 13 on protection type N. So, EXN, protection by NA, NC, NL, or NR. Specifically, we are looking at edition 5 of -15 60079-15 edition 5. Okay, first we'll talk about the order of precedence of EX documents. To verify and validate, one shall always refer to EX documentation in the following order: the certificate, specifically its conditions of use, limitations, and annex. Also, manufacturer's IOMs, installation, operations, and maintenance manuals. Then you follow the standard. Now, generally, client specifications, so end users such as Chevron, ConocoPhillips, their specifications shall usually go above and beyond the standards. But if they meet the standards, that's okay, but they shall not invalidate the 3 previous listed documents. When a conflict of it exists, refer to the highest number in that order. If there's a conflict between the manufacturer's documentation and the certificate, you shall follow the certificate. This is continuation on from last time, just teaching people where can you find certificates. ATEX ones are very difficult to find a lot of times. IECEx, go to the IECEx website. Very easy to use website. Follow the issue number, which means revision, as to what year it was manufactured. Not what year you installed it, what year was that piece of equipment manufactured. Everything can be found online on the online database, including certified persons and certified facilities. Now, when it comes to EXN or Zone 2 Category 3 equipment, there are considerations that must be taken into account when using within Europe or any country that has adopted use fully of ATEX. Under ATEX, Zone 2 Category 3 equipment is manufacturer's self-certification, meaning the manufacturer takes all responsibility, produces a declaration of conformity, and shall have type testing and routine tests done by an EXTL, test laboratory, that must be ISO IEC 17025 certified themselves. Now, the problem with self-certification is it's a biased evaluation aligned with the product underlying it. It dictates also the seriousness and the attention of the company making customers certain about the selected product covered by an indisputable certification of an accredited body. Now, this is said by Coretown. So what they're saying is self-certification, every manufacturer has humans working there, and the human fault will always be, our product is good, our product has no problems, of course it's okay. Do manufacturers ever know what happened to their products 10, 20, 30, 40 years later? Do they know if it caused an explosion? I'll ask you this. When an explosion happens, can anybody track it down to an electrical piece of equipment, or perhaps has that piece of equipment exploded and is no longer found? I would say it's no longer found. Now, are all manufacturers created equal? Certainly not. Do all manufacturers comply with ISO IEC 80079-34 quality management systems for manufacturers of EX products? Certainly not. So be aware there is a difference between ATEX and IECEx. IECEx equipment, Zone 2, GC equipment is certified, independently third-party tested and certified. ATEX, there's a weakness in the system there. So EXNs, remember we're talking about edition 5 of IEC 60079-15. It specifies the requirements for EXN. Now, the EXN types that currently exist are sealed devices, NC, hermetically sealed devices, NC, non-incentive components, NC, and restricted breathing enclosures, NR. Now, an important consideration is that the input voltage shall not exceed 15 kV volts, AC or DC, including the working voltages of the EX products, the internal workings of the EX products that exceed 15 kV, such as high intensity discharge lighting. The starters inside can exceed 15 kV. That is okay for the luminaires. Now, further clarification. EXNR, which has been removed, is for spark proof. No arcs, no sparks, no hot points. That seems to be very similar to EXE. EXR is housing with perspiration simplified. Now, an easy way to say that is restricts the entry of flammable gases. Restricts. NC, it's not flammable. It contains and extinguishes the flame. Now, let's go to the polls. Let's see if anybody has been watching our previous presentations and their input on this one. Is an IP67 rated and certified device, is an IP67 device rated and certified for IP66? Multiple choice. So these polls are anonymous, so please do not worry as to what your answers are. Give your honest assessment. Okay, let's share this. So the correct answer is no, and only if it has been tested and certified for IP66/67 is it rated for 66. The testing and certification is different. Please watch Index Online webinar 3, 4, or 4 and 5. They are not the same. Another question. This one's a preemptive one. It'll be answered in the next slide. EXNA has been removed and replaced by which EX type? Which EX protection technique? There's only one answer. EXNA. No arcs, no sparks, no hot points. Spark proof. No arcs, no sparks, no hot surfaces, high quality terminations. Okay, the answer is EXEC. Now the answers for EXE, I can understand the confusion, but remember that everything is now identified for EX protection techniques with the EPL letter included as well, ABC zone 0, 1, 2, or zone 20, 21, 22 for dust. So it has not been replaced by EXNC or EXD. Now let's go over definitions. Well, in the latest edition, they removed EXNA and enclosed break NC. So NA was non-sparking device constructed to minimize the occurrence of arcs and sparks capable of creating an ignition hazard. So no arcs, no sparks. That's exactly EXE. Now, enclosed break, NC, device incorporating electrical contacts that are made and broken that will withstand an internal explosion. Withstand an internal explosion. Well, they even say in the notes, the principal difference between enclosed break and flameproof are the dimensions are not controlled and safety factors have not been added. Now, those safety factors have been added, and it has become EXDC. So NA and enclosed break NC have been removed. So you can see the confusion. EXNC has multiple, well, used to have 1, 2, 3, 4, 5 different meanings. You'll learn the other ones as we go along. Hermetically sealed, what does that mean? It is a device that is constructed that it cannot be opened and is sealed effectively by fusion. By fusion, think of welding. That would be or cementing. That would be the easiest way to explain it. The previous edition of the standard said by soldering, brazing, welding, or the fusion of glass to metal. So now it's fusion of metal to metal or metal to glass. So just think of cold welding, hot welding, whatever it is, it cannot be opened. So how do you do an inspection? It's completely visual. Look for burn marks, melting, cracking. Now, non-incendive component. Well, it's a component having contacts for making or breaking a specified ignition capable circuit in which it is the contacting mechanism is designed and constructed so that the component is not capable of causing ignition. Now, the enclosure of the non-incendive component is not intended to exclude the gas atmosphere or contain an explosion. This is usually applied to special construction switch contacts, which are mechanically designed to quench or arc or spark that they are not a source of ignition. This one causes confusion for people, and it will continue to cause confusion. Basically, think of a junction box around the contacts. So it's kind of like EXNC. It's still inside of an EXNA junction box, perhaps, which is now known as EC. It's been made confusing. Now, sealed devices. Devices which is construction that it cannot be opened during normal service and is sealed effectively to prevent the entry of explosive atmosphere. So the difference between sealed and hermetically sealed is hermetically sealed means it has been welded shut. That's the easiest way to explain it. The non-incendive, it's components inside of something. Now, normally sparking device, well, we already know that. Normally sparking devices, switches, relays, contacts, not known to be EX protected. Now, what's EXNR? Enclosure that is designed to restrict the entry of gases, vapors, and mists. Now, is humidity a vapor? Certainly is. So, not only does it prevent the hazardous atmosphere from getting in and out, it also stops the humidity from getting into a cabinet. What about sealing devices? Well, a device employing a method to ensure, other than encapsulation, to prevent the flow of gas or liquid between equipment and a conduit before or between separate parts of equipment by providing sealing facilities. Now, what do they mean by that? Well, there was EXNC encapsulation type. That has been removed and changed to EXMC, M for encapsulation. So they're trying to make the standards easier to understand, but there's been a lot of changes and it can still be confusing. So let's go over it again. So in December 2017, 60079-15 came out, EXN. So hermetically sealed, it was deemed that it was already covered by the sealed device definition. Now, sealed encapsulated, did that become NC to MC? Perhaps the next slide may explain. Enclosed break devices are now designed as EXEC and are now found under 60079-1. So EXNC enclosed break has become EXDC. EXNA is now designed as IECEx 60079-7. There were other requirements added, such as test times for non-incentive components, additional documentation requirements for seals and gaskets, the pressure inside of cabinets when fans are involved, and limitations from edition 3 of this standard were also re-added. So what does that indicate? People made mistakes on the last edition of the standard. The last edition of the standard came out in 2011. So significant changes happened in 2011. They started including EPLs, GA, GB, GC. So just giving you an idea, EXE has now become either EB or EC. So zone 1 or zone 2. This is 2011. They removed EXNL. Energy limited became EXIC. Removal of encapsulated devices, encapsulated. So this is where EXNC became MC. Encapsulation 60079-18C, zone 2s. Well, and anything that mentioned about motors has now become EXEC, because that would be NA. NA has been removed. Motors, rotors, all those things. There's been a lot of changes, and it's understandable that people are confused. I do not hold that against any of you. So let's start asking some questions. EXNC, encapsulation, has been replaced by which EX type? Whoever just answered first, you got it right. So the problem with EXNs is EXNC has about 5 different meanings to it. So you have to pay attention to the words, the name of it. But then people have different interpretations. Industry confusion. Okay, let's share. So guys, those who answered EXM, that's not correct. It's only MC. If you say that, if you had an old EXNC device and you just told everybody it's exactly like EXM, you could have somebody install that in a zone 0 or zone 1 and potentially cause an explosion, potentially, because of your imprecise language. You must be precise. A, B, C. So it's EXMC is the answer. Encapsulation. Now, let's ask another NC question. I can find it. There you go. EXNC, enclosed brake, has been replaced by which EX protection technique? So it's enclosed. It's breaking the explosion. It's breaking the heat. The explosion is contained. Explosion, explosion, explosion. There's your hint. I saw the percentage move down on the one that everybody was answering with. Keep bringing that down, please. Okay. Okay, guys. Enclosed brake has not become EC. EXNA, which is our non-sparking and arcing equipment, is EC. Encapsulation, NC, has become MC. An enclosed brake, which contains the explosion and allows it to go through the opening and sufficiently cool, like the body acting as a heat sink, is EXDC. 77% of you were correct. Okay, next slide. So just remember, In 2011, we removed NL, which became IEC. Encapsulated type NC became MC. And in 2017, NC enclosed break became DC. EXNA became EC. It's the construction of it that you need to pay attention of. NA, remember, was terminals, no arcing, no sparking, exactly the same as EXE. Enclosed break, it's like a bomb-proof safe, flame-proof, okay? Enclosed explosion, enclosed, keeps it enclosed. EXD. EXEC, NC, encapsulation. Well, the word encapsulation is in there, so M, it became M. Now, as we said, EXNL was replaced by IEC in 2011. So why is it still used? Well, existing installations are still out there that are Zone 2. They're needed for spares and replacements. Is it still being installed? Well, only due to a lack of awareness and competence. They shall not be installed in new installations. You shall not use it. It is more than 2 editions out of date with the IEC and ATEX. You must follow the ATEX directives, which specifically has on their website dates of when you can even buy or the manufacturer can make this equipment. Now, most manufacturers have stopped selling NL. The only reason it's still sold, as I said, is spares and replacements. So NL, like EXI, is an EX system. This barrier, that barrier is EXNA, which must go into an NA box. But the circuit it's feeding is NL out to the device. But now, all of this would probably become EC with an IEC inside. So what's going on with EXNA? Well, in 2017, it was upgraded. I would say it's an upgrade to EXEC. Why is it still used? Well, existing installations of Zone 2. Spares and replacements. Why is it still being used? Due to lack of awareness and competence. Another reason is because under ATEX, there's specific cutoff dates. But unfortunately, under the IECEx, which is a voluntary system, manufacturers are allowed to use up to 1 edition back. So you can have a manufacturer creating a motor that's EXNA, a brand new certificate. It does not comply under ATEX, but it does comply under IECEx. Do all certification bodies know this, or testing laboratories? Not everyone is equal. Now, do all the manufacturers know this? No. Do all the engineers and the manufacturers and test labs and certification bodies know this? No. Do the end users know this? No. So here's a weakness in the system. ATEX allows Zone 2 equipment to be manufacturer self-certified. That's a weakness. IECEx allows manufacturers and certification bodies and test laboratories to use up to 1 edition back. The last edition was 2011. Significant changes have happened. Many manufacturers are still selling EXNA. So remember, NA is like EC or EXE. NA terminals inside of an NA box. NA terminals inside of an NA motor. If we look at this flame scanner or whatever this is from GE, Baker Hughes. Well, I'm telling you, inside of it is probably NL or IC. Yeah, but the housing of it is NA. Perhaps eventually they'll update it to EXEC. Now, the old one, EXNC encapsulation, which has become MC. Why is it still used? Well, Zone 2 only, spares and replacements. Unfortunately, some manufacturers are still selling EXNC encapsulation type NC because due to lack of awareness and competence. Question: why is it that installers and inspectors have to have competency, but manufacturers, testing laboratories, and certification bodies do not? If somebody has an engineering degree, does that make them competent? Competency is skills, knowledge, and experience. A degree only means you have some knowledge. With an engineering degree, that only means you've proven 15 to 30% of all competence requirements. So remember, when somebody tells you they're an engineer or they've been an electrician for 50 years, please do not let that influence you. Now, EXN 4.3, we talked about the EPLs. So once again, non-incentive, hermetically sealed, sealed, and restricted breathing. NC, 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 and R. The standards have significantly changed because they're trying to remove the confusion. I know many of you right now are probably confused. This can take multiple hours to go over this. Now, let's ask you a question. What is or are the weaknesses of ATEX Category 3 Zone 2 equipment? Multiple choice. Read the fifth one. That's an interesting case. There used to be the only EX drone on the market was EXNA, ATEX only. Why did it disappear? Read the 4 lines above. Okay, good enough. We'll share that. So, multiple answers here. Actually, all the answers are the correct answers. Manufacturer self-declaration. I say this is good. Of course, the manufacturer is going to say it's good. They want to sell a product. The lack of third-party involvement. Once again, not all manufacturers are equal. Do manufacturers know how to do type and routine testing correctly? Or do they do all the correct ones? Who's checking? Who's auditing them? No one. And that EXNA drone, well, that was an expensive drone that the company went under and went off the market. If that drone were to crash, would it cause an arc or spark? I would probably say yeah. Probably why it disappeared. Okay. Important considerations with Zone 2 equipment. Maximum surface temperature. This shall be determined with 60079-0. So the general requirements, when you refer to a standard, let's say -15 for EXN, you are not just following the standards of EX15. You must make reference to all the other standards listed within that standard. The surface shall be considered, the surface to be considered shall be the external surface of the equipment, including the surface of internal parts of non-incentive components to which hazardous atmospheric gas has access to. Now, EXNR, if gas cannot enter, Non-incentive components which the gas atmosphere has access. Have to think about that. This is often the outside surface of the type of protection NC components located within a level of protection EC equipment. There you go. NC components inside of an EC junction box. So increased safety, zone 2, EC. So commonly, NC components are inside of EC. This is where you have crossover between standards. You need to have awareness of this. There's a lot of information though. Now, requirements of electrical equipment, point 6. Specifically, they shall comply with 60079-0 and they shall have dielectric strength insulation from earth or the frame of the device. So what does it say? Well, you have to follow either a relevant industrial standard or anything not exceeding 90 volts peak or internal voltage is not more than 90, then it's 500 volts RMS, VAC, volts alternating current. For other equipment where it is in excess of that 90 volts, well, it's 2 times the voltage plus 1,000. So if you had 1,000 volts, it'd be 1,000 times 2, 2,000 plus 1,000. So it'd be 3,000 volts. Now, EXNC. So these are construction requirements. Requirements of hermetically sealed devices in which the seal is made by fusion of metal on metal or glass on metal are considered as meeting the requirements of a sealed device without testing. No further testing is required. The enclosure shall be capable of withstanding normal handling and assembly operations without damage to the seal. So that weld shall not come apart. Now, when we talk about sealed devices, sorry about that at the top, requirement for sealed devices, not hermetically sealed. So the difference is sealed, welded shut. Hermetically sealed is welded shut. Sealed means something that can be opened and closed without damaging it. Now, when the sealed device does not form part of the outer EX equipment enclosure, it shall be attested according to where the device is constructed with a separate housing and base that is sealed together. The housing and the base of the device are not considered part of the seal. So what they're saying is there's extra requirements, okay? EXN, there's so much to go over, so gentlemen, we have to go through at a decent speed. Now, EXNC, sealed devices. They shall be constructed that they cannot be opened in normal operation, but it can be opened during maintenance. Now, sealed devices that have a total free internal volume not exceeding 100 centimeters cubed, meaning 1 meter cubed, shall be provided where necessary with external connections. For example, fly leads or external terminals. So what are we talking about? Well, usually EXNC sealed devices, they'll usually just have a fly lead, which then you'll go to another, let's say EXEC junction box to make your terminations in. So this would probably be an instrument or a solenoid valve. Now, gaskets and seals, including poured seals, shall be positioned where they're not exposed to mechanical damage. Basically, they have to maintain their properties, sealing properties, over the expected life of the device. There are type tests involved. Now, let's ask a question. Why has the EXN standard 60079-15 been so heavily modified? Multiple answers here. So remember, there's manufacturers, test laboratories, certification bodies, procurement, designers, installers, inspectors, maintainers, operators. Okay, good enough. Okay, so the correct answers are the bottom four. For those who said to make more money, I honestly think that this saves a lot of money, the simplification of the EXN standards. There was 5 EXNCs. Now there's 3, but 2 of them are EX protection techniques with the outer housing being the EX protection technique, while the third one has to go into another EX protection technique. So NC's gone from 5 down to 3, but 2 can only be used on their own. NR has been simplified, NA has been removed, and NL has been removed. There used to be installations out there where people, I should say manufacturers, only mark them EXN. So that would have been NA, NL, NR, or the 5 NCs. We're talking 8 different meanings for EXN. I do not envy any of you trying to figure out old installations what the EXN means, especially when it's ATEX and manufacturer self-certified. That is absolute madness. So now perhaps you understand why they're doing these things. Simplifying the standards, simplifying the markings, reducing confusion, and consolidating the standards. So when we look at this, what do we have? Well, we have an end instrument, we have a junction box, and we have repeaters or barriers, isolators within the junction box. So this could actually be an EXNL and IC circuit and or EXNA EC. So what are we looking at? Well, the green units are EXNL. If they're old, they would be EXIC if it's the newer standard. Okay, so it was NL and then it became IC. NL, well, it can't be out in open air, so you had to put it inside of a junction box. What was the zone 2 junction box available? NA. So the NL went inside the NA, which fed an NL circuit out to an NL instrument. But as things have updated, we then, because of the standards updating at different times, these internals changed to IC. IC, can it be outside? Inside of a control room, as long as it's IP20. But when it's outside, in a hazardous area, zone 2 or anywhere, it has to be inside of an enclosure. So then you had them inside EXNA. Then as standard updated in 2017 from edition 4 to edition 5, well then NA becomes EC. So now the IC goes inside the EC, which feeds the IC instrument. Basically, these 4 different protection techniques, you have, depending on the year of installation or manufacturing, you have multitude of those options altogether. If you see an EXNA certified terminal like this, let me tell you something, it must go into an NA enclosure. IP54 minimum. Now, when somebody says that EXIC is not new and it has always existed, it did not exist until 2011. Okay? It's still new to many people. Have awareness of other stakeholders. People who are on existing facilities that are 10 to 100 years old have no idea what EXIC is. Perhaps they know EXNL. Now, EXN used to be compliant. Under ATEX, EXN only, just mentioning an N, was acceptable as long as it was described in the certificate. But the problem is the manufacturers are not all equal. So here's an example. This is an EXNA IA terminal. So what does that mean? Well, this is an NA terminal. Terminals feeding an IA circuit. Once again, this could have used to have been NL. So the NL circuit would feed to the NL device, but the terminals for it are NA, non-sparking. So it had to go into an NA junction box, which fed an NL circuit to a proximity sensor, flame scanner, vibration probe. Now this vibration probe, that is NA-NL or NAIC or ECIA. So there's multiple combinations. This is the confusion of EXNs. And as we've transitioned from EXNs. So remember, anything that is EXI and NA, there's terminals on there. It must always go into a junction box. I've had people fight this all the time. This must go into a junction box. And just because this says it's EXIA or something like that, that doesn't mean it's only EXIA. You have to consider the circuit. EXNL or I were 6 circuits, the complete system. You have to consider all of this at the same time. So a little more further details. So this is NA. Treat this as a terminal. Now, when they get updated, this will become an EC device. It'll be an EC terminal feeding an IA circuit. Now, what do we have here? Well, we have an Ethernet switch or port. Is it EXNA, NC, or EC? Well, a combination. The terminals are always going to be an NA or EC, but internally, it's NC. So what will change when it becomes newer is it'll be NCEC. The NC is internal, the EC is the terminations. So which junction box would it go into? Well, if it's EC, something newer, it has to go into a EC junction box. If it's an older installation, it's probably an NA junction box with the NANC device in it. Confusing, I know. So an HMI panel, human machine interface, touchscreen. What is it? Is it EXNA-NC or is it ECNC? When was it manufactured? Did the manufacturer update their equipment? Has it been certified recently? What junction box must it go in? Some of them only have to go into an IP54 junction box. Or maybe it goes into an EXEC junction box. Or maybe EXP, PY, PX, PY, PZ. Or maybe it goes into an EXD. Maybe. No, it would not go into EXD because it's not rated EXD. Now, here's an internal serial port. This was EXNA and NC, or maybe it was only NA. So what does it become? Well, it definitely has to go inside of a junction box. So what's happening? When was it manufactured? When was it certified? Is it ATEX? Is it IECEx? There's still a lot of confusion. Manufacturers, designers, Installer, everybody is still making mistakes on EXN all the time. Well, what is this? Looks like a pressure relief valve. So which EX protection technique is it? Well, it's EXNC. This one is the non-incentive, meaning it just has to be inside of a mechanical enclosure. That enclosure, it's not even, has it been tested for IP54? I'm unsure. But once you start getting into these things on the edges, which can be confusing, read the certificate, read the manufacturer's IOMs, installation, operation, and maintenance manuals. Now let's get into EXNR. It's only for Zone 2. It was used extensively for high intensity discharge lighting in place of EXD, because EXDs were expensive and heavy before LEDs. Now we have LEDs, which are EC, MC, QC, IEC. They'll have multiple EX protection techniques, but the outer housing is EC, so it can be polycarbonate. It's popular in the UK. It's a cheap method. Is it safe? Here's the problem with ATEX, manufacturer self-declaration. Now, if you involve a ATEX notified body like EXNB or other ones, well, they know how to do the testing, or I should say, know which testing has to be done, who it can be sent to. Now, does it have to have a test port? Well, if it does have a test port, then it must undergo type testing and perhaps routine testing by an EXTL test laboratory. And it's the manufacturer's responsibility. Shall be leakage tested after initial installation and at initial detailed inspection. So basically, after you've installed it and you're doing the initial detailed inspection, you do a pressure, an under pressure or over pressure leakage test. And after each time you do maintenance, every single time you open the device, you must do that test. And you must know what you're doing. And the certificate and the IOMs shall list to what pressure. Is it kPa? Is it inches of water? What are they going by? And it shall be done usually with an instrument hand pump. That's the easiest way. We're only talking 0.3 kPa or 3 kPa. If it does not have a test port, well, then the seals and gaskets must be replaced routinely, and it becomes the manufacturer's responsibility to specify that. Now, let me tell you, if you've ever dealt with lighting that doesn't have a test port, you have to change the seals every single year, according to some manufacturers. I've been on some facilities that are 20 years old. How many times in 20 years have they changed that seal that was meant to be changed 20 times? Zero. Absolutely zero. So what are we looking at? Serious source of potential ignition. Manufacturer pushing all responsibility to the end user. Now, markings, it's changed significantly. They shall comply with 60079-0. So in the old version of 0, it never mentioned you had to have A, B, or C. DA, DB, DC. That's EXD, flame proof. Yeah? Or EB, EC. That never had to be mentioned. That's where EXN used to be. You have to read every edition of all the standards to appreciate how things were in the past, how they are now, and how they may be in the future. For non-incentive components, marking shall include all the electrical parameters concerning the explosion safety, such as voltage, current, inductance, and capacitance as applicable. For small components, the requirement of marking may be included in the manufacturer's instructions. You can also find that under 60079-0, 29 markings, point 11, I believe. Very small pieces of equipment do not have to have the EX markings on them. But if a manufacturer does that, that's a very poor way of marking. And you'll find many installers will fail the equipment. So what are we looking at EXNR for lighting? So luminaire with EXNR lamp compartment and a separate EC compartment will be labeled EXECNR. Why? Everything shall be alphabetical now. Now, equipment without third-party certification, well then that's EXNR, purely just NR. Manufacturer self-certified. What do they have to do for markings? A lot of things have changed. You still have to follow the markings of 60079-0, but you also need to have the warning, do not open, maintain, or service in an area where an external hazardous atmosphere is present. Meaning, have your personal gas monitors, permit to work system, hot work permitry system, yeah? So documentation. The standards are telling you to do what the manufacturer tells you. At the very beginning, we said follow the certificate, manufacturer's documents, then the standard. That's what the standard tells you. It tells you to follow the certificate and the manufacturer, what they tell you. So a lot of things have been removed because all this was EXNA, the other type of NC, and NL. So information on the replacement of gaskets, of breathing enclosures, which do not include a test port. Information concerning the necessary for replacing gaskets in luminaires. Now, the reason you have to replace gaskets in luminaires is if it's not LED, that light is going to get very hot. So that gasket is going to expand and contract when lights go on and off. It's going to burn. That seal is going to become, well, less sealing. Now, information on the routine leakage testing of restricted breathing enclosures. Has it been tested for 360 seconds, 90 seconds, or 14? Now, instructions. Instructions shall be provided in accordance with the requirements of 60079-0. Hey, specifications for cable glands. EXN. Is there any EXN cable glands? Only NR. So if you have any other EXN type, you would just use the standard gland of D or E. But for NR, you must specifically use an EXNR gland. Information on the replacement of gaskets, once again, that's very important. Information on the replacements of gaskets on luminaires, very important. The electrical parameters for EXNC, non-incentive, and information about the testing procedure after installation during initial inspection should be provided. That should treat that as a shall. That is the requirement of the manufacturer. But for the installer and the inspector, your responsibility is to have that manual. Now, does your employer give you that manual? Perhaps. You should show them this presentation on YouTube. So, I want to thank everybody. We're going to open it up to questions now. NA and NL will be spoken about in this afternoon's webinar. N is just, there's 8 different EXNs over the life of the last edition 3, 4, and 5. Unfortunately, some people are working on old installations and are still working with EXNL. Some are still installing EXNL, which they shall not be. But their employers are having influence. So I'll go back to this as an example. We're going to open it up to questions. I will ask perhaps a few more questions here, get people's inputs. If a manufacturer marks their product incorrectly, What issues does this cause? Multiple choice. Okay, I'll share this now. Only 60% voted. Manufacturers, you've reduced your sales. Any procurement person or any inspector that sees your equipment will say this is, lack of better terminology, garbage. If you as a manufacturer have not marked your equipment properly, you're reducing your own sales. You're also increasing your insurance risks. Also, you're causing potential risks for ignition in hazardous areas. And all of these risks are dumped upon the end user. They take all the risks on cost, lives, environmental, and occupational health and safety. So if you do something wrong from the beginning, you're reducing, not only are you losing money, but you may lose money in the future after people die. Unfortunately, that has happened. Now, let's go to another question. Does the IECEx's allowance of manufacturers to use up to one addition, one revision back of the standard, cause issues? Okay, anybody that has the opinion of no, remember that is an opinion. Please come out to the field and see how things actually are in the industry. Watch any of our previous webinars. This confusion of EXN, the amount of people confused, confusion causes explosions. So please, here's a wonderful human factor. People do not like being told they're wrong. They will always disagree. I'll leave that up to you. If I say anything more to you, you'll just disagree more. Now, what critical type and routine testing must be done for EXNR? Sorry for the spelling mistake. Multiple answers. Okay, so the correct answer for EXNR, the type of testing, well, yeah, definitely IP rating or IP testing, definitely temperature testing, but also you either do an under pressure test, leakage test, or an overpressure leakage test. So all answers, but under or overpressure. Another question. So those who disagree, please tell me, as per the standards, what is the order of precedence? Which EX documents do you follow in which order? Do you follow a competency handbook? If you're told by, do you follow the Compex handbook? Or some other training body's handbook? In what order must you follow for documents? If you're unsure of something, do you refer the standards first or do you refer to the certificate? See, some people are shy to answer that one. Remember, it's all anonymous. So, gentlemen, you follow the certificate, the manufacturer's instructions, then the standards. You do not go straight to the standards. You do not go to the standards first. If you're sending your inspectors out without certificates, without the manufacturer's installation operations and maintenance manual, you are doing inspections incorrectly. You are putting your people at risk. You are not maintaining your EX protection. It doesn't matter if a piece of equipment is functionally safe and has a SIL rating. If that gas detector is not maintained EX safe, congratulations. It will measure the gas and potentially cause explosion of that gas cloud a few seconds later. Potentially. It's a good thing to have. So read the certificate, read the manufacturer's instructions, then refer to the standards. Next. That's all the questions. Now I'll answer people's questions that they've proposed. Can we do self-declaration for EXNA EC control panels without an ATEX certificate? Okay, that question's all over the place. NA panel, you could, if all of your internal components and the panel were manufactured before a certain date, let's say some date in 2018, and you assembled it. Then as a manufacturer, you can self-declare, declaration of conformity. EC, all of your internal components would have to be for EC. So all your terminals could no longer be EXNA. So at that transition period from one edition to another causes many problems for manufacturers. Okay? Is it mandatory that all internal components need to be EX certified? For EXE and NA, yes. Is there a protection technique that does not have to have EX components inside? EXP and D are 2 of 3 that do not need to have EX certified equipment inside. We spoke about the other one today. Will this be available on YouTube? Yes. This is a very difficult standard because it has changed significantly. And people, you got ATEX versus IECEx, you have manufacturers versus certification bodies versus installers, inspectors, every different stakeholder with a different opinion. So when people said you follow the standards first, that's an opinion. We've shown you directly from the standard today that says do what the certificate and the manufacturer's instructions tell you. So if you go to the standard first, you've gone to the wrong place. But at least it tells you where to go to. But most people do not think that way. They immediately go to the standard. If an LED is EXMB protected, free volume is less than 10 centimeters cubed, is it okay for zone? Okay, so that question is off base. It was EXNC, and there would not be an NC light, there would be an EC light. So that question I cannot answer. Does the ATEX directive equipment require inspection outside from EU and an inspection by an IECEx inspector? Let me explain things. The 60079 standards are 100% harmonization between the between EN and IEC. It's EN/IEC 60079. What is the difference between ATEX and IECEx? IECEx is much better in some ways. ATEX is a system that removed boundaries to allow for the movement of goods within the EU. If you are using ATEX in your country, you're probably using it because your country had nothing else to begin with when it came to EX protection. So it's good you use something, IECEx is a voluntary system. So can an IECEx inspector, IECEx COPC, a certified inspector, do ATEX inspections? Yes. It is much easier to go from a higher level of knowledge and understanding and higher quality management system to a lower level, such as Category 3, Zone 2 equipment being manufacturer self-certified, which is a lower form of certification. So if there's EXMB inside of an EXE luminaire, that MB probably has to do with a starter or a transformer, something like that. So an EXE luminaire is not just EXE. You'll never have just an EXE luminaire. It'll have other protection techniques internally for the other components inside. If it's EXD, well, you don't need to have any other EX protection technique inside. For those things, screen's not changing. I'm just showing this right here. I'm not changing anything. Now, if there's no more questions, give it another two minutes. See if anybody has any other questions. So I just want to make mention again. There's differences between ATEX and IECEx. ATEX Zone 2 is manufacturer self-certified. That's a weakness in the system. But under IECEx, manufacturers are allowed using up to 1 addition back. Once again, that's a weakness in the system. But a strength within the system, all of us can look for certified people, equipment, and facilities on the IECEx website. So where do you go first? When you're inspecting a piece of equipment, make sure that your engineer gives you the IECEx certificate. If you have a device that has an ATEX and IECEx certificate, get both. I'll tell you, the IECEx certificate is much easier to read than an ATEX certificate. Get both. If it has both, it's meant to say the exact same information. The testing has been the same and the information shall be the same. But the format of the IECEx certificate is much simpler to understand, and it's available for free online, and it's easy, simple to follow. Same for certified persons. Change this equipment certificate to certified persons and find yourself, me, or others that have done IECEx COPC. You can find me there under my last name, Michael Merrington, M-A-R-R-I-N-G-T-O-N. In an EXE luminaire, the LED is sealed, free volume less than 10 centimeters, but it is called EXMB. Is this okay? We're not talking about EXMB right now. If it's less than 10 centimeter, it should be. Unfortunately, when somebody says IECEx is valid in Europe and the UK, what is valid? The certificate of the person or of the equipment? Of the equipment, it's not. It requires an ATEX certificate within EU countries. But most good manufacturers of high quality do multiple certification at the same time. You get an ATEX and IECEx certificate at the same time. Now, can somebody that has an IECEx COPC certificate be allowed to do EX inspections throughout Europe and the EU, UK? Yes, but who has influence on that? End users. If Shell does not allow IECEx COPC, that's their decision, unfortunately. But it is changing. Some countries, like Australia, have EHA competency, electrical equipment in hazardous areas certification. But now IECEx COPC is accepted because you have an online database versus no database, versus audited systems by EX competent personnel or audited systems by government personnel who have no idea about EX systems. So Mr. J, who said that, thank you for bringing that up. For EC motor components, EXEC CTs, current transformers, differential currents transformers shall be certified together, or as long as it's EXEC certified. Okay, so an EXEC motor, any attached components, if it has a U cert, obviously also has to be EXEC. But if it's separately certified, now you're starting to get into IECEx assemblies, and that's a whole nother presentation. When you start getting into assemblies or non-electrical, mechanical and electrical assemblies, we're coming into a field that less than 1% of the industry has information on. Give it another 30 seconds. If there's no more questions, we'll end this presentation. And the one this afternoon, I'm specifically going to go in on NA and NL and the NC that became DC and MC. So this time we're down to 4 different types of NCs, while in the old version there used to be 7, and the one before that there was 8. Okay, thank you everybody for attending. We really do appreciate your time. And if you're unsure of anything, please watch this presentation again. Please shoot us an email. Our email is info@index-ex.ae. Anything on product certification, facility certification, inspections, personnel training, anything to do with EX, electrical instrumentation, mechanical, we can answer all your questions. This afternoon's webinar will only be on EXNA, NL, and the NCs that have changed. So we're talking about edition 4 and 3. One webinar for all EXNs is impossible. I do not have the time to get everything in 1 hour. Take a look in the beginning of this presentation. The link is there. In the chat window, you will find, and also I have now just posted. Thank you. Have a good evening. I should say good morning, good afternoon, and good evening. Thank you.